Hi, and welcome to the third part of my series on fractions. Today we'll be looking at doing equivalent fractions using a concrete, then a pictorial, followed by an abstract way. At the end of the lesson, we'll be discussing some essay type questions, so stay tuned. Can you recall us using the fraction wall in the previous video? This is a fraction wall. It consists of fractions that are equivalent to 1, which is the whole. This model, if you can recall, is the area model. So using this model, we are going to establish equivalent fractions. Suppose if we wanted to find fractions that were equivalent to a half. This means that I would have selected various strips and measure it against this strip to see if the area covered would be the same. For example, I may select a third. 1/3 does not cover the area of a half, so I may select another third. So now you can see that 2/3 is actually greater than the size of a half. This means that a third nor any multiple of a third cannot give me a half. Suppose if I selected another strip. If I were to select a quarter strip, 1/4 strip is not equivalent to a half. However, if I were to put a second strip that is equal to a quarter, then I would have 2/4. And 2/4 is equal to a half in length and breadth. So we therefore say a half is equal to 2/4. If I were to take a 1/6 strip, then 1/1/6 strip is not enough to cover the area of a half. However, if I added 2 more strips to make it 3 strips, then 3 of the 1/6 strip covers the area of a half, and therefore we can say 3/6 is equivalent to a half. What about if I took an 8? 1/8 is certainly not equal to a half. It is certainly smaller than a half. But what if I were to add another, and another, and another? We can see therefore that there are 4 strips of 1/8 that would give me a half. So that 4/8 is equivalent to a half. What about 1/10? How many strips of 1/10 do you think would be equal to a half? Let's add another, and another, and another. Yes. You can see there are 5 strips of 1/10 that would be equal to a half. So we can conclude that 5/10 is equivalent to a half. In summary, we can say a half is equal to 2/4, 3/6, 4/8, or 5/10. All these fractions are equivalent to a half. Now, let us take the argument a little further. Suppose if I had some number over 12 is equivalent to a half. What do you think that number would be? Well, if you were to use a fraction wall, then I'm sure you would have seen that a 6/12 is equivalent to a half. Let us see. Here's 1/12, 2/12, 3/12, 4/12, 5/12, 6/12. So there are 6/12 in a half. Now let us explore the concept of equivalence using a pictorial approach. Suppose if I had a checkered line book like this. If I were to represent a whole with this rectangular bar, note that I can have equal divisions within this bar to get fractions. For example, if I were to divide this bar equally into 3 equal parts, then each part would be equivalent to a third. Now let us see if we can derive some equivalent fractions for a third. If I were to take the purple section, which is a third, and I divided it into 3 equal parts, I will have to do the same for the red section and the blue section. So we can see a third is equivalent to 3 out of a total of 9 divisions. So a third is equivalent to 3/9. Note carefully, the space occupied by the purple section is equal to the purple section to the top. Let us see if we can derive some more equivalence. If I were to take the purple section once again and divide it equally into 2 parts, if I were to also do the same for the red section and the blue section, then the total number of parts would be 6. So 1/3, which is the purple section, would be equivalent to 2 out of a total of 6. Let us try dividing the purple section equally once again. Suppose if I were to divide the purple section into 6 equal parts. If I did the same for the red section and the blue section, then I will have a total of 18 parts. So a third would be equivalent to 6/18. We can summarize as follows. A third is equal to 2/6 or 3/9 or 6/18. What do you think a third would be equal to? Something over 12. What do you think the numerator will be? Again, here's another one. A third is equivalent to 7 over something. What do you think the denominator will be? Pause the video and try to see if you can work it out. If you said 4/12 and 7/21 respectively, then you were correct. A third is equivalent to 4/12 and it's also equivalent to 7/21. Now let us take an abstract approach to do equivalent fractions. Suppose if I had this to compute. We needed to find the numerator given the denominator. We have to consider what number we multiply the 7 by to give me 21. We multiply the denominator by 3, and you can recall a fraction remains the same if we multiply the numerator and the denominator by the same number. So if I multiplied 27 by 3, this would give me 2 times 3 over 7 times 3. This is equivalent to 6/21. So the missing number is 6. Now if I were to do the reverse, suppose if I had 6/21 and we wanted to find the denominator given that the numerator is 2. If 6/21 is equal to 2 over some denominator, then you need to ask yourself the question, what do I divide 6 by to give me 2? I say division instead of multiplication because we can observe that the number was reduced. And remember, we said when you multiply or divide the numerator and the denominator by the same number, you will get the same fraction. So if I divided the 6 by 3, I will get 2. Similarly, I would need to divide the 21 by 3. So we would have 6 divided by 3 all over 21 divided by 3 is equal to 2/7, because 21 divided by 3 is 7. The missing number therefore is 7. Now what's the takeaway? Multiplying the numerator and the denominator of a fraction by the same number gives an equivalent fraction. Secondly, when we divide the numerator and the denominator of a fraction by the same number, it gives us an equivalent fraction. The assessment component has 3 domains. The first of the 3 is called knowledge. Knowledge questions are the easiest questions because they require a simple recall. For example, if you are given 3/5 is equal to 12 over something, and you are required to find that number that is missing, this can be solved quite easily by knowing to get 12 you need to multiply the 3 by the 4. Keep in mind that you should know at this stage that when you multiply both numerator and denominator by the same number, the fraction remains unchanged. So your answer will be 5 times 4. Here's the thinking process. If I multiplied 3 by 4, that will give me 12. So multiplying 5 by 4 will give me the answer 20. So 20 is your answer. The second of the 3 components is called comprehension. Here's an example of a comprehension question. These questions are a little bit tougher than the knowledge questions because it requires you to work out a few things. If you were required to find the missing box, then here's what we can do. We can count the amount of equal divisions between 200 and 272. 1, 2, 3. Here is the point we wanted. 4, 5. We will notice that the red circle, which represents the unknown point, can be obtained because it is 4 out of 6 of the entire length. 4/6 of the entire length is the point in which we are referring to. But to get the entire length from 200 to 272, we must do a subtraction. 272 minus 200 equals 72. So what we really want is an equivalent fraction to 72 being the denominator. That is 4/6 being equal to something over 72. Since the something over 72 must be equivalent to the same 4/6. We can now take the same approach as we did in the previous problem. 6 times something is 72. What do we multiply 6 by to give me 72? The answer is 12. So to find x, all I need to do is multiply 4 times 12, which is 48. Having found that x is 48, 48 represents the distance between the 200-meter point and the red point. But remember, they asked you for the missing value. So what needs to happen to find the missing value? We need to add the 200 to the 48, and this will give me 248 meters. Now let us look at the third domain. The third domain is usually trickier than the two domains. This requires a lot of reasoning. Here's an example. To resolve this problem, the first thing I will do is recognize that it's 2 in every 75 students doing the SEA exam pass for the school of their first choice. My first reasoning is, if this is the case, then all of the students minus 2/75 of the students will be the fraction representing those students that do not pass for the school of their first choice. The next thing I will do, I will find out how much of this 18,750 is represented by 7375. This can be done in two ways, but for the purpose of this exercise, we are treating with the equivalent fraction way. So I have 73 out of 75 will be equivalent to something over 18,750. It is not as easy to determine what number we multiplied 75 by to give me 18,750. So what we do a division. Recall that fractions remain the same if we multiply both numerator and denominator by the same number, or if you divide numerator and denominator by the same number. If I were to divide 18,750 by 75, then this would give me 250. You can check this on your own time. But now that we know we are multiplying this 75 by 250 to give me 18,750, then I must multiply the 73 by 250 to give me the unknown number in the numerator. Okay, let's do the multiplication. We multiply by the 7 first, and we would have this. Then we multiply by the 3, and we will have this. When we sum the 2, we will have this. So therefore, the unknown number in the numerator would be equivalent to 18,250. Keep in mind that you need to show your working to get your maths. Thanks for watching, and I'll see you in the next video. Please don't forget to like and subscribe for future uploads.